of all, thanks for being here in my YouTube channel. Please subscribe our channel for more and more of electrical videos. Let's move on to the topic, that is Module 2A, continuation of single phase circuits, analysis with the phasor diagram of RLC. How exactly RLC will behave when we pass AC supply. And similarly, RL series circuit, RC and then RLC series circuits. Similarly, we are going to solve some problems based on RL, RC, RLC and parallel circuits also. Let's move on to the topic AC circuit with a pure resistance. So here resistance is connected across AC supply as shown in figure, that is V is equal to Vm sin omega t. Already we derived the equation from first module, right? So due to voltage, current will flow through the resistance R. The voltage drop across R is VR. I'll draw a diagram over here, waveform. So voltage and then current waveform. So for resistive load, current and voltage are in phase with each other, right? There is no phase angle. So vector diagram is like this, right? V and I is like this, right? So there is no phase angle. Phi is equal to 0, and I'll be giving a clue over here. So power is equal to Vi cos phi. So one just hint for derivation. So phi is equal to 0, power is equal to Vi cos 0. You will get power is equal to Vi, right? Cos 0 is equal to 1. So we are going to derive this equation. So I is equal to what? V by R, right? Where V is equal to Vm sin omega t divided by R. This Vm by R is maximum value Im. Im is equal to Vm by R. So you will get the final equation. I is equal to Im sin omega t. There is no phase difference in the current and voltage. Same equation. See here, voltage is this one. Okay. So see the diagram. Voltage and current are in phase with each other. This one is voltage, this is current, and there is no phase angle. So instantaneous power, see, power is equal to Vi, right? Everybody knows that is. So instantaneous power, alternating quantity, particular instant. So power is equal to Vi. So V is equal to what? Vm sin omega t. I is equal to Im sin omega t, right? So Vm, Im have taken outside, sin square omega t we got. So what is the formula for sin square theta? So 1 minus cos 2 theta by 2. Right, I just use the formula. So what happens? I'll convert it to sin square omega t, 1 minus cos 2 omega t by 2. So we'll get the equation like this. So finally, I'll rearrange the equation. So Vm Im by 2, Vm Im by 2 by into cos 2 omega t. See, this equation we got instantaneous power. This is called as constant term. This one is called as fluctuating time varying part. Varying part, right? So this here cos 2 omega t is definitely that's a time varying, because with respect to t will be there. Time varying part. Next there is an average power. How will we get average power? By integrating instantaneous power over 1 cycle, right? P average is equal to 1 by 2 pi is the base, because one full cycle we have considered. So 0 to 2 pi is the interval. P instantaneous, right? This part is this one, and then this part is this one. Okay. So we got the equation like this. I'll do next step. Okay, next step. So P average, I'll multiply this integration term and then 1 by 2 pi for both the term. Okay. So 1 by 2 pi 0 to 2 pi Vm Im by 2 minus 1 by 2 pi 0 to 2 pi Vm Im by 2 cos 2 omega t d omega t. Here also d omega t. Okay. This part I'll integrate afterwards, because I'll tell you how exactly this part will become 0. And then this part I'll integrate, okay? This part only. So P average is equal to 1 by 2 pi. So on Vm Im by 2 with respect to d omega t is a constant term. You will get Vm Im by 2 same as it is omega t 0 to 2 pi. This part as it is. This part, okay? So 1 by 2 pi. This one Vm Im by 2 pi minus Vm Im by 2 0. This part becomes 0. Only you will get this part, right? So finally we get P average is equal to 1 by 2 pi. 2 pi, this 2 pi cancel. We will get, okay, this part will not be there. P average is equal to Vm Im by 2, right? So this part becomes 0. Why? Because if you integrate cos 2 omega t, you will get sin 2 omega t. So after that, apply the limit 2 pi and then 0, you will get 0 answer, right? Sin 2 pi and then sin 0 is 0, right? That's why this part becomes 0. Only you will get this part, okay? This part will be there. So Vm Im by 2, we can write Vm by root 2, you can convert it to root into root 2. So Vm by root 2 into Im by root 2. So that is Vrms into Irms. So finally we got the equation as power is equal to Vrms into Irms. Next there is a power voltage current waveform. Okay, so this one is power, this one is voltage, this one is current, right? So see, for example, power is equal to Vi, right? So both are positive, we'll get power is positive. Suppose I'll be giving 2 into 2, 2 is voltage and 2 is current, we'll get 4. So this one is 4, power is 4. And again power is equal to minus 2 into minus 2. This is minus 2 and this is minus 2, you get 4 is the answer. So same thing you will get it, same power, right? So always the pure resistance power is positive, will not get negative power in the pure resistance. There is a AC circuit consisting of pure resistance 10 ohm connected across AC supply, that is 230 volts, 50 hertz, right? So calculate current. We need to calculate current. Current is equal to what? I is equal to V by R, right? So V is equal to 230 volts is given. R is 10. We'll get 23 amps. Next is the power. Power is equal to what? Vi cos phi. For resistive load, cos phi will not be there. Cos phi is equal to 1. So we'll get only power is equal to Vi. Cos 0, because voltage and current are in phase with each other. Phi is equal to 0. Keep it in your mind. So voltage is 230 into current is 23. You will get 5260 watts. Next there is a equation of voltage and current. So equation of voltage is V is equal to Vm sin omega t and I is equal to Im sin omega t. So how to calculate Vm? Vm is equal to what? Root 2 into Vrms, right? Correct, right? So V is equal to root 2 into 230 sine of omega. How to calculate? Omega is equal to 2 pi f. So omega is equal to 2 pi into 50. You will get 314. Okay. So sine 314 t. This is the equation. And I is equal to Im is equal to root 2 into Irms, right? So root 2 into 23. You will get sine 314. These are the equation for voltage and current. Okay. Equation of voltage and current. Translate the answer. See here, 23 amps and 5260, and if you want to calculate this one, root 2 into V, so root 2 into 230, you get 325, root 2 into I, 32.52, and omega is 2 pi f, and 314 radian per second, and V is equal to this one, I is equal to the equation. Next, there is a AC circuit with a pure inductance. So pure inductance is connected across AC supply as shown in figure. V is equal to Vm sin omega t. Due to voltage, current will flow through the inductor. When rate of change of current occurs, what happens? It induces flux. Due to this induced flux, produces induced EMF. VL is equal to L into di by dt. Right? So this induced EMF always opposes the supply voltage according to Lenz's law. See here, this is a supply voltage, and then this is the induced voltage. Right? And also, inductance stores the energy in the form of magnetic field. Also, it opposes the change in current. Right, so I'll be drawing one diagram over here, waveform of a lagging phase. This is the voltage, okay, this is the current, and this is voltage, this is current. So pi by 2 exactly, this is pi, and 3 pi by 2 and 2 pi voltage and current axis, right, x-axis omega t. See here, current lags by voltage at an angle 5 by 2, phase difference, right? So I'll be drawing a vector diagram from that waveform. So this is voltage, this one is current. So lags at an angle 90 degree, right? I'll be giving one clue over here. Power is equal to Vi cos phi, right? The AC equation. So phi is equal to what? 90 degree. So I'll substitute over here. Vi cos 90. So we'll get Vi into 0. So we'll get power is equal to 0. The pure inductance does not consume any power. We are going to derive now. And also by common sense, here we got Vm sin omega t is a reference. See here, it lags by 90 degree. Definitely I is equal to Im sin omega t minus pi by 2 or 90 degree. We'll get it. The equation. Next we derive the current equation. So V is equal to what? L into di by dt. We want this di, right? So I take left hand side. Di is equal to V by L dt, right? So what about V? V is equal to Vm sin omega t, di as it is divided by L dt. So if you want I, you have to integrate, right? So Vm by L outside, so sin omega t dt. What about the integration of sin omega t? Definitely minus cos omega t by omega, right? Vm by L into minus cos omega t by omega, right? So Vm by omega take outside, omega L cos omega t, Vm by omega L sin omega t minus pi by 2. Correct, right? So we can write Vm by omega L is Im according to Ohm's law. Omega L. You can write Im is equal to Vm by XL. XL is equal to what? 2 pi FL. So inductive reactance. Right. So we can write I is equal to Im sin omega t minus pi by 2. I just substitute here. Im sin omega t minus pi by 2. Vm by omega L is Im. Okay. So this is the equation of current. Okay. Next there is a, I already explained this one. So this is a vector diagram. This is a waveform over here. Next there is a instantaneous power. The instantaneous power equation. Power is equal to Vi. This is a standard equation. So where V is equal to what? Vm sin omega t, and I is equal to what? Im sin omega t minus pi by 2. This sin omega t minus pi by 2 I can write minus cos omega t, right? So Vm Im sin omega t minus cos omega t for rearranging the equation. Okay, so we'll get Vm Im sin omega t cos omega t. We'll get it, right? So what about the sin 2 theta formula? Sin 2 theta 2 sin theta cos theta, right? So if you want sin theta cos theta, so sin 2 theta by 2, right? The trigonometric formula. So similarly I'll apply over here, minus Vm Im sin 2 omega t by 2. So this is the equation. Okay. So power is equal to minus Vm Im by 2 sin 2 omega t is the instantaneous power equation. Next there is the average power. How will you get average power? By integrating instantaneous power over 1 cycle, right? P average is equal to 1 by 2 pi is the base, 0 to 2 pi is the interval. So P instantaneous. This instantaneous power is this one. This part is area under 1 full cycle is this one. So after integrating with the limit of 0 to 2 pi, sin 2 omega t is converted into cos 2 omega t by 2 omega. If you apply the limit, here minus will be there, plus 1 minus 1 you will get. So it becomes power is equal to 0. So the pure inductor does not consume any power, right? So next we'll move on to the power voltage current waveform. So power waveform is this one, and then voltage is this one, black line, and then pink line is current. Okay, so I'll be considering interval A, B, C, D, E. Okay, so case 1, A to B, here current is negative, voltage is positive, so negative power. See, negative power. Okay, next there is a voltage is positive, current is also positive, positive power, that is B to C, positive. And next there is a current is negative, voltage is positive, so negative power, so C to D, negative power. And then D to E, see, voltage is negative, current is also negative, positive power. This is positive, this is negative, positive, negative. So positive power is equal to negative power. It becomes in over one half cycle, you'll get 0 power. Power is positive, power flows from source to the inductor. If suppose power is negative, negative power, so inductor to source. By observing this diagram, so we'll come to know the pure inductor does not consume any power. Next we'll solve one problem. A pure inductive coil allows a current of 10 amps, right? And 230 volts, 50 hertz supply. And we need to calculate L value, and we need to calculate power also, power observed. Directly we can write 0 because pure inductance does not consume any power. And then equation of voltage and current, I is equal to Im sin omega t minus pi by 2. So for resistance, keep it in your mind, only omega t will be there. What about voltage? V is equal to Vm sin omega t, this is constant. for all L, C, R. So we'll calculate L value now. So XL is equal to what? 2 pi FL. L is equal to XL by 2 pi F. Right. So how to calculate XL value? Inductive reactance. So XL is equal to V by I. Right. So we can take directly values 230 by 10. 230 divided by 10. So we'll get 23 ohm. Right. So I'll just substitute here. L is equal to 23 divided by 2 pi into 50. You will get 0.073 Henry. Okay. Next, there is a current and voltage equation. So current we need Im, right? So I is equal to Im is equal to what? Root 2 into I is 10, right? Into sine of omega is how much? Omega is equal to 2 pi f. So just to calculate, we will get omega is equal to 314. So 314 t minus pi by 2. Directly we get. So v is equal to root 2 into 230 VRMS value sine of 314 t. Can calculate this one, this part and this part. You will get this one is 14.14. This one is 315.52. Okay. This is a problem. 23 we got, and then L is 0.073, power is equal to 0. This one is we got 14.14, and then this is 325.25. Next, there is a AC circuit with a pure capacitance. So the pure capacitance is connected across AC supplies as shown in figure. The supply voltage V is equal to Vm sine omega t. Due to this voltage, current will flow through the capacitor, so the capacitor gets charged, and energy is stored in the form of electric field. So Q is equal to CV, right? Q is the charge and C is the capacitor, V is the voltage, right? And also I is equal to dQ by dt. The supply voltage V is equal to Vm sin omega t. We need to determine current, right? I, right? So I'll be drawing one waveform over here. There is a current leads by voltage at an angle 5 by 2, right? This is a current. So this is voltage. This one is current. Vi will be there. So this is 5 by 2 pi, and this is 2 pi, right? 3 pi by 2. So see here, I'll be drawing vector diagram also. So current leads by voltage. So definitely voltage is here and then current is here. So anti-clockwise direction. So at an angle 90 degree. So I'll be giving a clue over here. Power is equal to what? Vi cos 5. So cos 90 definitely 0. Power consumed by the pure capacitor is 0. We are going to derive now. Right. We'll derive the current equation. I is equal to dq by dt, where d by dt as it is, q is equal to cv. So d by dt as it is, c into vm sine omega t, right? V is equal to Vm sin omega t, supply voltage. So Vm C outside and d by dt of sin omega t. After differentiating Vm C as it is, sin omega t differentiation cos omega t into omega. So Vm C into omega cos omega t. So I can write Vm by 1 by C omega. Okay, 1 by C omega cos omega t. So this part I'll write xc. So xc is equal to 1 by C omega, or xc is equal to 1 by 2 pi fc. 2 pi is f is omega, c is as it is. So in ohm. Okay. So I'll write I is equal to Vm by xc. Cos omega t I can write sin omega t plus pi by 2. If it is minus cos omega t, sin omega t minus pi by 2. Keep it in your mind. Okay. So I is equal to Im sin omega t plus pi by 2. Right. Where Im is equal to Vm by xc is a formula. Right. So we got the current equation as Im sin omega t plus pi by 2. So see here, current leads by voltage at an angle 90 degree. See here, directly we can write over here I is equal to Im sin omega t plus pi by 2 before deriving the equation. This one is V is equal to V is equal to Vm sin omega t. Just to remember like this. Plus for capacitance, minus for inductance. So next it is a instantaneous power. How to determine instantaneous power? Power is equal to Vi. Okay, Vi. Similarly, Vm sin omega t is V and Im sin omega t plus pi by 2 is I. Just you take Vm Im outside, you will get sin omega t. Again sin omega t plus pi by 2 is cos omega t. So again formula sin 2 theta is equal to 2 sin theta cos theta. So sin theta cos theta is equal to sin 2 theta by 2. See, this one is sin 2 theta by 2. We got the equation like this. Next, there is a average power. How we will get average power? By integrating instantaneous power over one cycle, right? So P average is equal to 1 by 2 pi is the base, 0 to 2 pi is the interval, P instantaneous. This instantaneous power is this one. And this area under one cycle is this part, right? So if you integrate by the limit of 0 to 2 pi, the sin 2 omega t becomes cos 2 omega t by 2. So after applying the limit, so you'll get cos 2 pi and then minus cos 0. 1 minus 1, you'll get 0 answer. So the pure capacitor does not consume any power. The power becomes 0. Let's see the waveform of power, voltage, current of capacitor. So this is power. This is voltage, black line. This is blue line is current. Just to consider. So I'll be mentioning interval A, B, C, D, E. So case 1, I mean AB, both are positive, voltage and current are positive, power is equal to VI, so positive power, right? And then case B to C, voltage is positive, current is negative, negative power. So and then here negative voltage, negative current, so case C to D, so positive power. And then D to E, case D to E, negative current, positive voltage, will get negative power. See here, positive power is equal to negative power in one cycle. See here, right? So the average power becomes 0. The power consumed by the capacitor becomes 0. If suppose power is positive, the power flow from source to the capacitor. If suppose power is negative, the capacitor is discharging. So power is flow from capacitor to source. We'll solve one problem. A 318 microfarad capacitor is connected across, this is a play that is 230 volts 50 hertz, right? So 230 50 hertz and 318 microfarad. So we need to calculate capacitive reactance, XC we need to calculate, and then RMS value of current, I we need to calculate, and then equation of voltage and current. I is equal to Im sin omega t plus pi by 2, plus pi by 2 for capacitor, minus pi by 2 for inductor. V is equal to Vm sin omega t is a constant for all inductor, capacitor, RL circuit, RC circuit, whatever it may be. So how to calculate Xc? Xc is equal to 1 by 2 pi Fc because C is given. So we will get Xc is equal to 1 by 2 pi, F is 50, 50 into C is how much? 318 micro into 10 raised to minus 6. You will get 10 ohm. Current we need to calculate. So capacitor reactance over 10 ohm. Current is I is equal to V by Xc. So 230 by 10, you will get 23 amps. Next, we need to determine this equation of voltage and current. So equation Im is equal to what? Root 2 into I is equal to root 2 into 23 sin omega. I will get see here omega is equal to 2 pi f. You will get 2 pi into 50, 314. Okay, so 314 t plus pi by 2. Okay, and voltage V is equal to root 2 into 230. Okay, sin 314 t. So this is the equation of voltage and current. Directly you can, if you can solve root into 23, that is also okay using calculator. Just to multiply these two. So that's all. We'll cross check once again. 10 ohm, 23 ohm. So directly apply root 2 into VRMS is 325. So maximum is 32.53. Omega is equal to 2 pi f. So finally this part is root 2 into 230. Okay. This part is root 2 into 23. Okay. This part. That's all.